Hello students, hope you are all in a good condition and healthy condition. So today we will continue to the next chapter, which is chemical equilibriums, especially in the concept and the constant. Especially we will discuss about the concept and the constant. The rundown of today's class had been posted in the Teams. So I hope you have checked it all and read some of the flip material I gave in the wiki Teams. The chapter of the chemical equilibrium will be divided into 4 sections as in this chapter. So look at this section. The first one is chemical equilibrium, the concept. The second one is expression of chemical equilibrium constant. Those two will be discussed in today's lecture. And then the following week, we will discuss the third and the fourth, which is the utilities of chemical equilibrium constant and factors that affecting chemical equilibrium constant or Le Chatelier principle. So let's start out with the connection between this topic and the previous topic. Remember, the previous topic is rate of reaction. So what is the connection between rate of reaction and chemical equilibrium? Knowing whether a reaction takes place quickly or slowly can give important information about the process in question. If the process has health implication, for example, the information can be especially crucial. Sooner or later, many reactions will appear to stop, but that simply means that two reactions that are the reverse of each other are proceeding at the same rate. When this is the case, the reaction is said to be at equilibrium. The study of chemical equilibrium gives information about how to control reactions, and including those that play key roles in life processes. So remember, your study of chemical equilibrium here will give you insight how to control reaction, and then how to define the reaction of equilibrium will go toward products or toward reactants. And it is very important in life processes too. Let's continue with the definition and the nature of chemical equilibrium. So the definition of chemical equilibrium or dynamic equilibrium, or we can just call equilibrium, is a dynamic state in which the rate of the forward reaction is equal to the rate of the reverse reaction. Remember, the underlined words here is dynamic state. It means the equilibrium always moves. It is dynamic. Next, what about the nature of chemical equilibrium? The natures of chemical equilibrium are briefly explained in the 4 items below. Look at this slide. The first one, it is a dynamic state. Second one, at equilibrium, there is no change in concentration of either reactants or products. However, the reaction is still taking place. The fourth item is reactants are still being converted into product and the product into reactants. But the rates of the two reactions are equal. So those are the principle or the nature of chemical equilibrium. Now let's move to the second concept of chemical equilibrium. We will talk about equilibrium constant. Within this subtopic, we will talk about 3 items. The first is the math of K. The second is the nature of K. And finally, we will talk about the magnitude of the K. So now I want to trigger you to discuss in a group and talk about the math of equilibrium K in a 3-minute game. Let's look on the slide. So I want to trigger you with the search of math of equilibrium in a 3-minute scheme. Grab your pen or pencil and a piece of paper. Then do this simple math and try it out with your group of 3. Look back first the definition of chemical equilibrium. Then write down your math equation from the definition. You can go back to the previous chapter, reaction rate, if you forgot, and then do the math calculation from that definition of rate of reaction toward chemical equilibrium. Remember, you have general formula of reaction rate in the previous chapter. So the hint is remembering the rate of reaction expression last time. Write that rate forward reaction equal to the rate of the reverse reaction. Write that in a math formula of an equation. If you are correct, then you will end up with K as a constant value. This is the K which has been called as equilibrium constant. Consult your textbook on page 223 to 226 and also try this link. I provided the link also in the Teams. So now, go to your subgroup in the Teams and discuss with your groups, and we'll be back in 3 to 5 minutes to the general Teams group. Thank you. So thank you for the discussion in the subgroup Teams. Now that you have discussed about the K formula, starting from your math equation, let's continue with the equilibrium constant definition here. So equilibrium constant, or K, then can be defined as the product of the concentration of products of a chemical equilibrium divided by the concentration of reactants, each raised to the power equal to its coefficient in the balanced chemical equation. Look at this general reaction A plus B, which each of the coefficient A and B small, and then the product will be C plus D, which coefficient C small and D small. So we can then calculate or formulate the equilibrium constant expression as K equal to concentration of C powered by C, the coefficient, times concentration of D powered by D, the coefficient of D, divided by concentration of reactants A and B, and each powered by the coefficient. So this is the formula, general formula of equilibrium constant K. So what is the application of that K formula? Let's take a look on the example here. The problem is you want to mix H2 gas, hydrogen gas, and iodine gas, and it reacts at 427 Celsius in the following equilibrium: I2 plus H2 becoming 2HI. The equilibrium concentration of I2 is 0.42 m, H2 is 0.025 m, and HI is 0.76 mole per liter. So using these values, let's calculate the value of K. So then you put the K is the concentration of products powered by the coefficient, which is HI powered by 2 divided by I2 times H2 concentration powered by each of coefficient is 1. Don't forget to always write down the unit of concentration, and in this case is m, molarity. So the K will be, if you calculate correctly, you got 55. This K has no units because molarities cancel out each other. Now let's take a look on the equilibrium constant, the nature of equilibrium constant. So what about the nature of K? First, there is no relationship between a reaction rate and the value of K. Reaction rate depends on the activation energy of the forward and reverse reaction. These rates determine how fast equilibrium is reached, but not the position. It is possible at the equilibrium state, you will have large K but slow rate. It is also possible that you have small k but fast rate. And it is possible to have any combination of k and rate of reaction. So there's no relationship between k, the bigger, the smaller, with the faster or the slower reaction. So next, with that nature of chemical equilibrium constant, then come up also the idea of the magnitude of K. What about the magnitude of K? So let's see the next slide. On the magnitude of K, I want to trigger you to discuss also in your groups, go back in your subgroup teams, and discuss in your group these two questions. The first one, what does it mean to have a large K, a small k, and a very small k? What does it give the state of chemical equilibrium? Secondly, how will you use the information of K values? What is the context? So, refer the textbook, your textbook, on chapter 7.6 to discuss about the magnitude of K. It could be large K, and what is the effect of the chemical reaction, the chemical equilibrium. It could be small k and very small k. What are the effects? Discuss that in a group within 10 minutes ahead. So after your discussion about the chemical equilibrium and the constant, the magnitude of chemical equilibrium constant, then this is your assignment. Your assignment is a 1-minute video. Record a 1-minute video of one of the topic below. The first one, how to express the math of K as equilibrium constant. Secondly, explain the magnitude of K and its effect toward chemical equilibrium. To make you easier to make the 1-minute video, so I will divide it into 2 big groups. And each group will do one of the topics above. Group 1 to Group 4 will do the number 1 assignment. Group 5 to Group 8 will do the second assignment only. So this assignment is part of the chapter assignment. Give me the link of videos in the assignment box which I assign in the general themes. So that's all about the assignment, and I hope you can get the assignment as part of your meaningful learning. So this is the end of my lecture, but the class is still going on. I will stop talking and I will go around into your subgroup, Group 1 to Group 8, and we can discuss in each subgroup any questions about chemical equilibrium concept and the constant. And then if you have any questions regarding the assignment, I will also be happy to answer the assignments and everything we have discussed today. I welcome also any comments regarding the assignment. So remember, this is the word from Marie Curie. Be less curious about people and more curious about ideas. So with all of that, thank you to join this class, and I will go around the subgroup to discuss with you. Thank you.